Yes, hey, welcome back. And yeah, as you know, yesterday I solved the rat in the maze problem where you use recursion to tell all the possible ways the rat can get out of the maze from the given start point to the given end point. And I thought, yeah, since I solved rat in the maze, let's solve the problem called two knights problem. And yeah, again, the question is pretty straightforward. You will be given a chessboard and you'll be given two knights, and you have to tell how much time, or not how much time, but how many moves does it take for the first knight to attack the second knight. Yeah, it can be called knights attacking problem also. And yeah, again, I hope you understood the question. I'll reiterate it. You will be given a chessboard, and two knights will be placed somewhere on the board, and you have to tell how many moves does it take for the first knight to attack the second knight. And yeah, that's basically the problem statement. And so let's directly go on to solve it. And again, for this, rather than using recursion, you use depth, not depth first search, but the breadth first search. And in each iteration, what you do is you keep track of all the possible places the knight can jump to. And then, yeah, again, start breadth first search from that point itself. So the worst case time complexity will be 2 to the power of 8, mainly because the knight can jump in 8 ways. Yeah, so let's directly get on with it. So let's define. Yeah, again, I have I thought let's make it more pictorial. So I have the emojis of white block, black block, white knight and black knight ready over here, the Unicode. Yeah, so now let's define the class. Let's call it knight gems. Yeah, we'll have a lot of initialization to do. Let's currently not do any initialization, and as we require something, we'll do the initialization. And so yeah, now let's define the object of our knight. So uh, knight gems, and yeah. So what we'll do is we'll have one function called calculate, which will do all the required things for us. So yes, calculate. We will call the calculate method. And yeah, so now let's define the calculate method, which will take in self mainly because it is inside the function. And yeah, so what will it get? So you will get the size of the board. Let's keep it 8 for now. And then you will get the start point or the position of knight 1. So let's keep it at 0, comma 0. And yeah, again, you can make it so that the size of the board is always 8, and you will give A6, A5 like that in just terms notation itself. Yeah, but there the initialization has to be done a little bit differently, and it makes no difference. And yeah, let's keep the other knight in the other end of the board. And yeah, so again, so what you'll get in self in calculate, you'll get the board side. After self, don't forget to give a comma. You get the board side and knight one position and the knight two position. And yeah, so let's have a board object over here. And separate board is actually null over here. We are not directly initializing it with the constructor, but we are using a different thing called calculate, and put a pass over here. And yeah, so you'll have self dot board size. Initially it is 0. Self dot knight one x. The x position of knight one, which is 0. Again the same for knight two. Yeah, knight two, knight one, knight two. So you'll have knight one x, knight one y, knight two x, and knight two y. Initially that's all set to 0. And yeah, I think currently we need this much, and we'll let us initialize them. So self dot board size is actually equal to the board size. Self dot, yeah, board. We have just initialized the board. Like we do not need the board now, but we'll need it afterwards. And self dot knight on x. Knight on is x is actually equal to knight on at the position 0. Yeah, don't put anything unwanted. Yeah, again, you need knight 2x. Knight 1 y. Let's go in order. Yeah, is actually knight 1 at the position 1. And yeah, again you have to do the same for knight 2 also. So knight 1, yeah, let's call it knight 2x and knight 2y. Knight 2x, knight 2y is actually knight 2 at the position 2. Yeah, let me spell properly. Knight 2 at the position x and at the position y. And so yeah, now I think it's better to get the DFS part out. So let's directly call the DFS function over here. So and let me define the DFS. It's not DFS. Don't make mistake like that. It's actually BFS. Again, it will not take any arguments because we have already initialized everything we want. SELF. I hope I can spell right today. And I hope you know how BFS works. So what you will do is that you will go through the next neighbors and the next neighbors. Like you won't directly go completely into it. You just check out this neighbors and its neighbors. And yeah, again to do BFS, the one thing which you need, you can either do it recursively or iteratively also. But I prefer iteration. So for that you like need DQ or double-ended queue to hold the data and pop it out. So it's present in the collections framework. So from collection, let's import DQ, and you will actually have will be an object of DQ which actually has self dot knight one x and self dot knight one y, and while true, yeah, while q exists, let's pop out the x and y value, which is the current x and current y. So x comma y is q dot populate, and yes, now let's just check it out if it's happening properly. So let's print out the x and y values. So always be sure to print and check whatever you're doing. And let's break out of the loop so that we won't be stuck in some infinite loop. And yeah, according to this, what should happen is we should get 0, 0 as the output. And yes, we got 0, 0 as expected. That means our initial part is working properly. And now, yeah, think of the edge, like the end case. So when will the thing end? I hope you understood. When we have to stop, we have to stop when x comma y becomes equal to knight 2x and knight 2y. In other words, they are attacking each other. So if x becomes equal to not triple equals, it's not JavaScript. And again, you have to put self over here. Knight, I spelled two wrong. QOW, QW, this one is not on right. Yeah, knight 2x and knight 2y. And knight 2x, yeah, knight 2x and y becomes equal to knight 2y. That means you have actually hit the other piece. So what you'll do, let's return true for now, and we'll look about calculating the path afterwards. So or else what you have to do, you have to have a visitor set so that you don't keep jumping back and forth. Yeah. Yes, and just add the currently added one to the visited. Yeah, I forgot to add self over here. And yeah, but before adding, what you have to do, you have to check if the current points are like valid or like inbound. So if yeah, I hope you know how to check. So if x becomes greater than 0 or y becomes greater than 0, that means you have gone a negative index and you don't want that. Or x becomes greater than or equal to board size, or y becomes greater than or equal to board size. Again, don't forget self over here. Or the x comma y exists in visited. That means you have actually, again, don't forget that self. I don't know why I'm doing that. That means that the position is actually invalid. So you will directly continue to the next iteration, or else we'll add the current visited nodes to the set, which is x comma y. And then for you have to, like, now what you have to do is you have to go in all the directions possible. And yeah, knight, be careful of this. Knight does not go like plus one, zero comma one, zero comma one, minus one comma zero, like that. And you have to be very careful of that. Knight actually jumps in L shape. I hope you know how to play chess, or at least you know how a knight jumps. And okay, let's just represent it at once. Yeah, and whenever you're having difficulty imagining the coordinates, just directly draw it out. So imagine your knight. Imagine this to be the origin. So this will be 0 comma 0. And yeah, let's give two spaces to everything. No need. Yeah, let's give two spaces to keep it consistent. Yeah, better way to, rather than going individual and clicking on everything and giving two space, it's better to do like this. And yes, yeah, initially the knight will be in 0 comma 0. Knight of three spaces, I think. Yeah, let's make it, whatever you're doing, just make it look more appealing, like make it more visual so that you won't get confused what you're doing. Yes, knight is at 0 0. And first L, how it can jump? It can go up, it can go up, it can go to the left. And yeah, better do one thing, fill all the coordinates out. So this is 0 comma minus, it is 0 comma minus 1, and it is 0 comma minus 2, and this is minus 1 comma minus 2. This is minus 2 comma minus 2. And yeah, this is 1 comma minus 2, and 2 comma minus 2. I hope you're understanding how I'm feeling this. This is like pretty simple, so I'll not go deep into this. And this is 1 comma minus 1 comma minus 1, and then it will be minus 1 comma 0, and then it will be minus 1 comma 1, and then it will be minus 1 comma 2. Whoa, 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 what is this? It is minus 1 comma minus 1. Yes, and this is minus 2 comma 1, minus 2 comma 0, minus 2 comma minus 1, and this is not 1, this is minus 1 over there actually. And this is 1, and minus 2 comma minus 2, minus 2 comma 2. There should not be any negative over here. I don't know why I'm doing such killing steps. Yeah, this was a chore to do, but hey, we have to work hard to gain something. And now let's correct everything so that it's proper. Yeah, and let's keep 0 0 as the center. And the most value taken is of the cell. So Yeah, see how good it looks. And yeah, you are at 0, 0. So the first point which you can go is up, up, and left, which is minus 2 comma minus 1. So let's have a self dot direction over here. Yeah. And we'll fill the array over here and then paste it over there. So you can go up again, up, and left, which is minus 2 comma minus 1. And then again, you can go up, and right, which is minus 2 comma 1. And then you can go left. If you go left, up, you'll again reach 2 comma minus 2 comma minus 1. So since it is already taken care of, you can go left, and then up, which is minus 2 minus 1 comma minus 2. Yeah, and over here, so you can go, if you go right, up, you'll reach minus 2 comma 1, which you don't want. So you go right, up, which is minus 1 comma 2. And then, yeah, you can go down, left, which is 2 comma minus 1. You can go down, right, which is 2 comma 1. Yeah, let me just show it. Down, right, which is the 2 comma 1. Again, if you go down, you reach 2 comma 1, which you don't want. But you can go right down, which is 1 comma 2. And then you can go left down, which is 1 comma minus 2. Yeah, just check it out if all the like directions are proper. So you have minus 2 comma minus 1. You have 2 comma minus 1. So you have 1 minus 1 comma 2. You have minus 1 comma minus 2. You have minus 1 comma minus 2. And then you have 2 comma minus 1. And then you have 2 comma 1. And then you have 1 comma minus 2. And then you have 1 comma. So yeah, this seems to be right. So let's just cut it out. And yeah, that is our direction array. These are all the valid ways in which a knight can jump. So now for the coordinate in range length of directions, yeah, extract the x and y value. So dx comma dy will be x plus self dot directions at the position called. This is your forward. So all, yeah, and zeroth position is actually the x value, and it will be y plus self dot directions at the position called at the position 1. I hope you understood why it is like that. And yeah, if you want to go to neckline, you can directly add a slash indicating the Python that there is actually the neckline which you have to go. And yes, again, you have to check if dx comma dy is valid. So when will dx or dy will be valid? Again, when the not of the above condition holds true. So let's define it in its own function. So yeah, again, I think it's better we call it. Yeah, it's that is valid. That's a good name. Again, since it is a function, it's inside a class, so we have to have self over here. And this will actually take into value, which is x comma y. And yeah, I think we can directly copy this value. Yeah, this means it's not valid. So or else you return true. If x becomes yes. And now we can actually replace this with is valid. If it is not valid, again you have to add self for it. If it is not valid, of what? If the x comma y is not valid, then continue. And then if is valid, with dx comma dy, that means that yeah, the given range is the given coordinates are not only inside the range but also not present in the visited set. So now we have to continue the BFS from that part. So how will you continue the BFS? Since we are using iteration and not recursion, we will directly add it to our queue. There is no self over here. The dx and dy will add it. And yeah, and on top of adding the, I think Yes, and yeah, that's all it. I think let's just yeah, believe it or not, your entire recursion should be done by now, and let's just run it out once to check if we have made any mistake. Yeah, I think I forgot a comma over here. Yes, and yeah, let's print to just check if are you reaching the true condition. And as if we were reaching the here condition, that means that the knight can actually attack each other. And yeah, this is basically the crux of the operation. Now what we have to do is let's represent it visually so that it looks more good. So again, for that, what we have to do, we have to first generate the board and then generate all the coordinates of the places where our knight jumps so that we'll get to know what happened where and when so that we can move our knights accordingly. So to move our knights accordingly, to generate the coordinates, but we need a default dictionary to store the value. And yeah, let's self.path is actually default dictionary of type list. And yeah, what you have to do if the current position is valid. So yeah, just think about it. What does that mean? That means that that position can be reached from the previous position. I hope you understood. If the current position is valid, that means that position can actually be reached from the previous position. That means self dot that is actually a path, and the path at the position what the current position can actually be reached from the previous position. I hope you understood what this means. This is actually really important to understand what that means, or else you will never get to know what is happening. And yeah, let's just print out the self dot path over here. And yeah, this is actually a very big board. So let's do one thing. Rather than 7 comma 7, we'll place it in 1 comma 1. So theoretically, that should be here in two moves, which means we should get okay. Yeah, theoretically, the knight should reach here in two moves. Mm, is x comma y 0 comma 0 and so from 0 comma 0 you can reach to all the yeah it's saying this much big because of all the possible like it should be 3 into 8 I think. So it has that many number of elements. So now let's just filter out the valid path. That means if you have reached the end position, that means x comma will y will actually be in the end, and you have to check you have to generate the path from x comma y to knight one x and knight one y. In other words, the initial position. So just yeah, while the x comma y is not actually equal to dot knight one x and the self dot knight one y, you have to generate the path over here. So yeah, let's call it generated path because we have to store the values over here. So, yes, and let's remove the slash over here. I don't know why I added that. So again, yeah, if you are on x and y, that means that is an actual path. So generated path dot append the current coordinates and then change the current coordinates to its parent coordinates. And that parent coordinate you'll obviously get it from our path over here. So you have x comma y. X comma y is actually equal to self self dot path at the position x comma y. Yeah, let's just run it out to check if we are stuck in some infinite loop. And yeah, we are not stuck in some infinite loop. That means it is working properly. So let's print the self dot path. No, no, let's print the generated path. Yeah, and you see it's happening. Let me just remove the here and path over here. Yeah, from just taking from 1100. Yeah, I think it's better we just represent it out once. So from 1 1 you are going to 0 3, 0 3 to 2 4, 2 4 to 1 2, and that is the actual path we have to take. Uh, yeah, according to our this one, knight one is over here, and then knight two is over here. So first what you have to do from 0 0, and now the keep note of this, the generated path is actually in reverse order. So from this one it is actually going to 1 1. Yeah, I think for that again we have to like let's take it to be over here and here and here, so that we don't have to rewrite the entire array. So from 1 1 it has to go to 0 3, and let's just add a 0 3 over here, and 0 3 will 1 2 0 1 0 2 3 comma 0. Yeah, 0 3 should come. Yeah, from 1 1 it has to go to 0 3, which will actually come over here, and yeah, we'll add 1 comma 3, and we'll add the 2 comma 3 over here. So from K2 it's going left, left, up. From 0 3 it is jumping to 2 4, and 2 2 2 3. Okay, it's jumping to 2 4. Okay, from here it's going here. 2 4 is going to 1 2. Yeah, and from 1 2 it's actually reaching 0 0, and that is the path is not actually added over there because we are prematurely stopping it. And after this we have to again add the current reached path, self dot generated path, append the initial position, so which is nothing but the night 1 x and night 1 y. Yes, now let's print out. And yes, as you see from 1 1 it's going to 2 4, 1 2, and it's going to 0 3 first, 0 3. Yeah, and from 0 3 it's going to 2 4. So like this, and the top, and then down down, and then the right, and from 2 4 it's actually going to 1 2, and from 1 2 it's actually, and from 1 2 it's actually reaching our required position, which is 0 0. And yeah, that means that you have actually implemented the the DFS and the path calculation efficiently. So give a pat yourself on your back, and yeah, now the major part of the operations are done. And now let's remove this. That means after BFS, what will happen is that you will actually have the generated path. So again, print everything what you're doing. Let's just print out the generated path over here. And yes, you're actually getting the generated path. Yeah, just add some def statements over here, or the test statements, so to test if you are actually calling it from the correct method. And yes, over here you actually have the generated path. So now let's generate the board first. Again, which will take itself and nothing else. And yeah, I hope you know how a chessboard looks like. So let's just look at a chessboard once. And yeah, where is a good looking board? Yeah, let's look at this board because it is good looking. So what will happen? The first block is actually black, and then white, and then black, and then white, and it goes on. And again, the first block of the second column is actually black, white, and then black, so on. So what does that mean? Let's just write yeah, again, to get the logic to generate the blocks. What you can do is you can again write down the entire rather than writing the entire thing. We'll just check for the first three rows, and you'll get the actual logic on how you can generate it. So yeah, and let me remove the, yeah, and yeah, now just let's just look at these three rows. And yeah, no, no, I will actually look from 0 0 to 2 2. That is actually the most proper way to look at it. That will be more easy to look at it rather than proper. Yeah, now look at it. So 0, 0 is actually black and it's even. Like if you take 0 and 0 and add it, it will become even. 0, 1 is actually white and it's odd. Like 0 plus 1, it will become odd. 0 plus 2, it's even and it's actually black. 1, 0, the sum of them is odd and it's actually black. 1, 1, it's actually white. And 1, 1, the sum is even and it's actually white. 1, 2, the sum is odd and it's actually black. And yeah, it goes on like that only. So whenever it's even, the sum is even, that means it should be a black board, like a black square. And whenever the sum is odd, it should be a white square. I hope you understood how it came. Again, just write out the coordinates and note it down once. Even before I was brute forcing it, and then simply I thought, okay, I brute forcing the entire board and putting the black and white coordinates. But then I thought, okay, let's just look at all the values once. And when I looked at it, I saw a much more easier way to do it. So in generate board, what we'll do? Yeah, fine. Yeah, you actually have the board size over here. Yes, we actually have the board size. Yeah, I don't think. Yeah, we'll put that values in the board itself. So for you have the board size for call in range self dot board size. Yeah, again, if the sum of row and call, so if the sum of them modulo 2 is actually equal to 0, that means that it's actually a black square. So we'll have a temps variable over here. That means this is actually a black square. So let's append the black square value over here. So let's just define that. Let's go black square and that for white square and yeah, we have to have one for white square and then you have to have one for black knight and white knight also. Then you have to have one for yeah this entire thing both. Black knight, white square, black square. Yeah, let's just copy. That's why I had already stored this value. So you have white block or white square, and this is the white square, and then this is the black square, and then the black knight, and then the white knight, and then you have the white knight over here. So okay, now what you have to do? Again, think about it. If the sum of row and the column modulo 2, if it is equal to 0, that means that the actual square is black and the sum is odd. That means the actual square should be white. And yes, I'm out of charge, so let me just plug it in once. And yeah, so again over here, if the row plus column modulo 2, if it is actually equal to 0, that means the current block is actually black. So we'll append the black box, black square, else white square. And then after each iteration, that means that the row is generated. So let's add that to our self.board. And yeah, I think now our board should be generated. So let's just print it to tones. And yeah, I should call the generate board over here. And let's remove this because it's not essential. Generate board. Yeah, hope for the best and hope the actual calculation is done properly. And yes, it looks really good and perfect to me. Black, white, 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 black. Yeah, perfect, perfect. And now what you have to do? Now you have to actually place the knights also. So self dot board at the position self dot knight one x and knight one y. Knight one x at the position knight one y. You have to actually place the self dot white knight or black knight, whatever you want. Let's just put the white knight over there. Self-built board. Again, we have to again write the entire thing. So let's just copy it and paste it. And again, over here it will be y. And let, no, no, no. My bad, my bad. It will be x over here. But it will be 2. And knight 2y. It will be the black knight. And now let's print out the board again. And as you see, white knight is over there. And what happened to this? Yeah, I think for white knight, I have copied the wrong value. Okay, white block. And as you see, for white knight and white block, the values are actually similar. So let me just check out the values of white knight, black knight one. Yeah, the one what we are missing is actually the black knight. So yeah, let me just rewrite this all the values because they are obviously wrong, and I don't want to like waste my time on checking which value is wrong and why. So the black square is actually slash u, and it is 2b 1b, and the white square is actually slash u 26 by 8, and then the black knight is actually again slash u 2b 1b 2b 1b, and yeah, black square is actually 2b 1c, I think. Okay, again I don't know why I'm making so many mistakes. The black square is actually 2b 1b. Yes, correct. And then the white square is actually 2b 1c 2b 1c, and then the black knight is actually 2658 2658, and the white knight is actually 265e. Yeah, that was a real harsh. 5e. Yeah, now let's get printed out once. And yeah, we have the white and black knight properly placed. And as you see, the white knight is actually smaller than the square. So what we'll do is we'll just add a space over here. And now you see it's perfect. They're actually occupying their required amount of square. And now again, majority of our work is done. So what we'll do again, we'll extract the print board in its own function. Again, it will not take any, it will take the array to be printed for row in range length of array for call. Okay, let's just do this for call in range the length of array. Okay, okay, my bad, my bad. So what you have to do, just print the array into position row at the position call, and the ending delimiter is actually not slash n. So ending is actually a space, and after each loop, print the next line, or you can there's no need to add slash n over here. And yeah, let's just check out our let's just check out if our print board function is working properly. Print board. Okay, it is actually in line 39. It's on 38, 39. Yeah, tell dot black knight. And you have to pass the self dot board over here. And as you see, it's actually working perfectly. And yeah, I printed it out like that because we don't want to obviously see those commas, brackets and all. Now it's looking much more cleaner. Yeah, everything looks fine. So now the last thing left to do is to actually simulate the night movement, the final hurdle in our journey. So let's call it def simulate movement, which will again take in self. So again, think about what you have to do. You have the actual generated path, and using the generated path, you can actually get to know where the knight jumps. And as soon as the knight jumps, take the previous path, take the x and y value, mod it, and if it is equal to 0, that means that path is actually a black path. That piece, not the piece, that position, or else it is a white path. So for I in range 1 to length of self dot generated path. So you have the correct and the curve y. Let's call it chord because it's actually the coordinate. So you have correct and curve y to be actually equal to self dot generated path. Where is generated board? I don't have any generated board. Yeah, I don't know why it's suggesting generated board, mainly because I don't have any generated board function defined over here. That tripped me up a lot. And just let's remove it for now. Generate path at the position code at the position 0 and self dot generate path. Okay, I think the generated board is actually in maze or somewhere. That's why it's actually getting called over here. Yeah, generated board is actually not there. I don't know why it's suggesting generated board again and again. At the position code at the position 1. Again, I do the same for previous x and previous y. It is actually previous x and previous y. And over here it will be the negative one position. And yeah, so what you have to do, take the knight and move to the current position, and then take the previous position and mod it, and yeah, accordingly update the square. So self dot generated board. I think I have generated board. No, it's just board over here. No, board at the position cur x at the position cur y is actually equal to self dot. I think we are moving the black knight, so black knight, and yeah, if previous plus pre y. Yeah, and don't forget to add the brackets over here. I was like super confused on why I was getting wrong values. Module 2, if it is equal to 0, that means the current path was actually a black box. So board at the position uh, free x, the position free y is actually a black square. Else it was a light square. It's actually a white square. And yeah, I think by now it should be done. So let's just print out the board over here to check if our simulation is happening properly. We'll have dot board. And yeah, you should call the simulated movement over here, or else it makes no sense. Simulate the movement. And yeah, as you see, the knight vanished and white knight got replaced by black knight. That means your entire work is done. So just rather than printing it over here, now what you have to do, let's import time so that there is some time delay between each printing loop. So import time. After each loop, you want to have some actual time limit. Yeah, and it's self-dot print board, yeah, self-dot board, yeah. And then yeah, after and before printing each code, let's have a slash in. You want to have a slash in over here, and then a slash in over here. And yeah, rather than making it like this, so let's use the F string because F strings look cool also. And remove this, and add this one over here, and add a F over here. Yeah, that's all. And after printing each board, let's just sleep for I don't know 1.5 seconds. Okay, then why is that happening? Because that was not happening beforehand. It is happening at index here at the position row at the position column. Happening over here. And 40. It's not happened. Why is that? Call it zero for me. Okay, yeah, something is obviously not right. Mm, I think, yeah, I think it's because we're passing the actual. Oh my god, what am I doing? You can't actually pass flash and all inside print board. That is actually handling everything. For what? Yeah, as you see, it is actually jumping in the perfect way, and that's what you want to see always perfection. Yeah, let's do one thing. Uh, Before we call each board, let's just print flash and let's have two flash and after printing the entire board, print flash in because yeah, yes, 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 and let's go. That's what you want to see. Looking at that makes me very happy, and I hope you also felt happy on seeing the board work and on seeing the code working so good. Jump, jump, jump. Yeah, okay. The thing is that it's not actually showing the initial board also. So what we'll do is before starting the simulating movement, we'll just print out the board once. Print board, self dot board. Yeah, that's what you wanted to see. And after that, we'll just for 1.5 to keep everything consistent. And yeah, let's go. Look at that. Look at that. I think that is actually the shortest way. Is there any other shorter way to do that? One, yeah. If you even if you go like this, one and two and three, yeah. Whatever you do, that is actually the shortest path. And yeah, let's just place the knights on some different places. So let's just place it at the end of the board. So place it at 7 and 7 and just see it once. Yeah, look at the black knight jumping all around like a madman. And let's go. Yeah, the black knight took the head of the white knight. Yeah, what you want to do is, I think that's all it. And if you want to make it so that the white knight is actually the black knight, just swap around these values. It does not matter. Yeah. If you are like I always want to see it from the perspective of white, then you can obviously do like this. Then you'll see that it's actually attacking from the perspective of white. Yeah, I think that was pretty cool, and yeah, that's all for it. Let's just increase the zoom once so that it looks good. Yeah, now let's check it out. Yeah, perfect L shape jump, perfect L shape jump, perfect L shape jump, perfect L shape jump, another perfect L shape jump. And yeah, after that, it directly took care of business. Yeah, let's just print it out for like one more finally. And let's have 10 squares, and the knight is at I don't know. Let it be at 3 and 4, and it is at 9 and 0. Yeah, that looks like good positions. Yeah, let's print it out. Yeah, okay, yeah, jumping very good, jumping very good, and there goes the black knight. That's what I want to say. Let's go. Yeah, I hope the video is informational, and yeah, it was a very fun project to do also. And yeah, that's all for it. Just look at what is DFS first, how to do it, and all to understand this. And yeah, grind more days so you can do it. And yeah, keep on learning new things. And thank you for watching.